very motivating.
She doesn't get mad. Just sometimes when I start something else, she slaps me. It works.
I did not suspect that from Brady. It's like corporate.
Oh, I asked her to do it.
Oh, you okay? I was like, if you just does it,
Hey guys, don't forget, phones go into the lab, earbuds out your ears. Pick up, hand out a copy, the card for today. There is some graded work over on the side counter from last quarter.
Good morning, Woodson High School. So far, you are in the hallway and please stand to the pledge of allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands,
One nation, under God, indivisible, liberty and justice for all.
You may be seated now that the prayer will be silent. Now to the announcement. Newly printed Underground for Valentine's Day on sale starting Wednesday, February 1st through February 13th during March of the Buy $1 candygram, $40 Valentine's. Related to our senior day at the school in room C123, please join us in our site events. ATE Mentor. The next meeting of the ATE Mentor will be today from 4:30 to 6:30 in room L126. Spring sport tryouts are right around the corner. They start on Monday, February 20th. In order to be able to try out, you must be registered, do a sport, and have a sports physical turned in. Have questions? Go to Ms. Committee in the activities office. Seniors, there are 225 of you that still have not paid senior dues. Senior dues are $20 and must be paid before you can pick up your traffic gas for graduation. Questions? See Ms. Committee in the activities office. We will have our next Model Judiciary Club meeting today at 3:10 p.m. in room B124. There will be a PSU movie tonight after school today in K101 to celebrate the first day of Black History Month. Good morning, Miss This is Dr. Floyd with an important message about our bathrooms. So,
Oh my God.
are consistently being clogged and overflowing in the boys' bathroom as well as the single-use bathrooms, resulting in only one boys' bathroom being available yesterday. Please understand that clogging toilets is inappropriate, causes thousands of dollars in damages, and is completely unacceptable, especially as this is high school. I expect appropriate behavior. I expect all of our students to act appropriately and take care of our school. We need to show pride and respect for our common areas, as this is a one-listening community. If you have any questions or would like to discuss this, please stop by the office to see me. Thank you very much, and let's have a fantastic Wednesday.
Attention on that, one more announcement. Second period teachers, a reminder, if you have 9th, 10th, or 11th grade students in your classroom, right now, we hand them the course selection sheet and label. Students, you should get a label. Go ahead and put the label on your course sheet as soon as you get it. We hand those out right now. Any junior going on a history field trip today, make sure you get your course sheet before you leave class for that field trip. If anyone needs any extra sheets, teachers, you can send a student down to student services to get some to bring back home to your classroom. Please hand those sheets out now. Thank you.
I don't think I missed anyone with my initials, but as I said earlier, so when I start talking, you need to stop talking. Excuse me, baby juniors. As a junior, when a teacher starts talking, you stop. As I mentioned earlier in the science section, I have initialed pretty much everything that you can take. I kind of put it over a big chunk because there's so many available. You need to show this to your teachers today. It will be collected tomorrow at the end of the day. So that's all you get it for. Don't lose it, don't leave it at home. That's it, that's all you get it for. Today and tomorrow. Today and tomorrow. You turn it in to your 7th period tomorrow. They collect it and it goes to counselors. This is not set in stone. You will meet your counselors face to face and they will schedule you. Okay, so they're not going to take this paper and make your schedule from it at all. You will be sitting in the room when they type in your courses that you would like. So don't panic about that. Please don't lose them. And does everyone have a label on theirs? But
I didn't see mine there. I don't know. I missed it.
did you double check?
Yeah.
Triple check?
I'll quadruple.
Nothing wrong with quadruple. Why wouldn't I have had a label for you? Please double check no one has hers. Nope. Here you go. So your name and ID. Hold on. Let me find it. So you can take physics and these. Sure. Anyone else missing one? Anyone want me to make my initials clearer because of the class you want to take? Yeah.
Can you sign up just because of the AP Bio?
Didn't I put it over the whole thing?
I just
Yeah.
want to be sure because it's not touching it and I don't want to cancel anything. Yeah. Just like mine is off. Thank you.
Yeah, but I totally, AP Bio should be your senior year. But that's okay, you guys do what you want to do. Please know your junior year is harder than your first and second year at university. Mainly because of Woodson. You go, oh, I'm taking 5 AP classes. Oh, I'm signed up for 5 AP classes. And then you want to sign up because your friend signed up and everything. Ask them what they're taking next October. Because they will have dropped out of 3 of them. So just keep that in mind before you set yourself up for hell on earth. I would love to. Not that we're all not all okay with hell on earth. Where's one? Oh, is there a field trip? No, yes. Is there? What's happening? I thought the field trip was for juniors and seniors. These are not juniors and seniors. It says right here, grade 10, grade 10, grade 10. What else could be going on? Does everyone feel okay? Yeah,
Sarah's at a doctor's appointment.
okay. Anyone know anything else?
I mean, it's snowing, so they probably
They thought it was gonna be a snow day?
probably clear, so. Yeah.
Okay, as long as it isn't like norovirus going around or something. That would be my own personal nightmare. Okay. Oh, everyone copying the card. We're going to take some notes on the last type of reaction. We're going to cover this unit before we get into all the labs, this unit. So we're putting the notes up front, and then you'll be doing the activities so you know what you're actually looking at. Also, you want to remember there were 2 worksheets you guys had last class. I told you only to do the front of one in class, and then the oxidation numbers. We're going to be working on the back of that one today. And everyone should have picked up another one. I need to actually get that one. I guess you guys can pick up that graded work later. Happy February. Oh, okay, so let's see, what's my next slide say? What's my next slide say? Oxidation reduction reactions. That's what we are talking about today. Now, it says here they are reactions in which electrons are transferred from one reactant on the left-hand side of a chemical formula to the other reactant. So you're not going to see this in a decomposition reaction because you need more than one reactant. Okay, one reactant to the other. Now, many of them absolutely involve oxygen, but it is not required to be oxidation. It's just a nice little happy accident that those words are similar. Okay. Yeah, so rusting of iron. You guys know what the symbol of iron is? Fe. And its oxygen is O2. Both of these in elemental form, right, have no oxidation state. But when they come together and they make FeO, what are our charges here? Oxygen's -2, so what must iron be? +2. And then combustion of a hydrocarbon. Which one do we want to use? CH4 and O2. Again, it's going to go from having nothing or zero charge because it's elemental form. And then what do we get? Our CO2. And what's it going to be over here? Well, oxygen's -2, but they're, yep. And H2O. So where did it get those electrons from? From the other reactant. Where did this oxygen get those extra electrons from? From iron. Okay. Now, you can have oxidation reduction reactions without oxygen, and a lot of them are without oxygen. So just because the word is redox or oxidation reduction, it's not required to have oxygen. This is just showing you sodium metal and chlorine gas, both in their elemental form, with no oxidation state, and in the solid form, we know it's +1 and -1, right? So we have electrons being transferred between the reactants, and that makes it a redox reaction. This pretty simple? Cool. Now, the transfer does not have to be a complete transfer, okay? So this picture is, and not a complete transfer, meaning you don't have to get an ionic compound, right? HCl is a covalent compound, so it's just unequal sharing. So it doesn't have to be a complete transfer. So here, when we hydrogen gas and chlorine gas, we just get a polar molecule. This guy, it was a complete transfer because we got an ionic compound, right? The electrons are not shared, they're taken. So it works for both ionic and covalent compounds. That's all this slide is saying. And this is just pointing that same thing out. Now, this is what your card says. Oxidation is the loss of electrons. Oxidation is the loss of electrons, and reduction is the gain of electrons. So we go back to the beginning where oxygen went from 0 to -2. Was that oxidized or reduced? It was reduced. It was reduced. Just because it's the element oxygen, it was reduced. And reduction, yeah, so oxidation is the loss, reduction is the gain. So there is, I think there's a slide that shows you, hold on, is there? Okay, maybe not. So couple mnemonic devices. One is called oil rig. You know, an oil rig sits in the ocean, right? So oil is your oxidation is lost. Rig is your reduction is gain, each individual word to help you remember. Another one, which I never quite liked, another memory device is Leo Gur. Leo Gur. Leo being a lion, so lions go Gur. So gain something is reduction and loss is oxidation. I don't like Leo Gur.
I think, is the E electron?
Yeah.
Lost electron output.
Loss of Leo, gain electron, and it's reduced. Lost electron, it's oxidized. Right? So Leo Gur versus oil rig. I like oil rig better just because it seems to make more sense to me. Oxidation is loss. Loss of what? We're talking about electrons. So you lose electrons. Reduction is gain. Gain of what? Electron. So, now, we need a method for determining how electrons are transferred that don't involve metal, nonmetal, or combustion. So that's what the oxidation numbers are for. So we know rust is that metal, nonmetal, and we got combustion. We're going from elemental to carbon dioxide. But the oxidation number is what we use for kind of everything else to figure out if something is a redox reaction, if any of ours are redox reaction. And we already went over kind of the oxidation state rules last unit, right? Are we comfortable with the oxidation state rules? Yeah. So you'll see them multiple times. Free elements have an oxidation state of 0. Monatomic ions, their oxidation state is just whatever the charge is from the periodic table. Hydrogen is +1 when? When it's with a nonmetal, and it's -1 when? When it's with a metal. Cool. In this class, we're going to go with oxygen being -2. But it can be -1 in peroxides, but that's pretty much for next year. So, and then these are, yep, we've gone over all that. So let's see. We want to get started and try to figure this out?
Yeah.
Yeah? Okay. So on the worksheet from last class, we assigned oxidation numbers on the front. But let's look at the back. It shows us a reaction, and Cr2O7, and it says it's -2. So this is an ion, and it is reacting with an iron ion. And it's giving you some of the products, not all of the products. It's giving you Cr +3 and Fe +3. So obviously there's more going on because there's no oxygen over here. Does that make sense? So you're just looking at a couple pictures, a couple parts of a reaction. Now, we can see between the reactants and the products, it's very clear to see that iron's oxidation state has gone from +2 to +3, right? So we know that iron has gone from +2 to +3. Now, to do that, what had to happen? F2 had to lose an electron. So when it has to lose an electron, it means it's going to be on the electron's going to be on the product side. So it's losing one electron. Does that make sense? So Fe2 loses one electron, and now it's Fe3. So what's losing an electron? Oxidation is loss, right? So this is oxidation. Now, something's going on with the chromium, but we've got to figure that out, right? We got to figure that out. Do we remember how to do it? All of the sum of these have to equal -2. We know oxygen is -2. We're not sure what chromium is, but there's 7 of them, so this is -14. -14 plus what will give us -2? Hopefully you guys are saying 12, right? But there are 2 chromiums, so each individual chromium is +6. So +6. So we know that chromium is going from +6 to +3. How did it do that? It had to gain electrons. How many? Right. So when it's gaining electrons, that goes on the reactant side. It has to get them to equal that. So gain 3 electrons. So what these are called, and this would be reduction. So chromium is reduced in the reaction. Iron is oxidized in the reaction. Okay. And this and this, each one of these are called half reactions. Half reactions. Now, you can't have one without the other, right? You can't have oxidation and nothing else. It's oxidation reduction. So this is 1/2 of the yin and yang, right? So that's why they're called half reactions. Now, looking at this, well, we can keep it at that, but I'm going to teach you a method probably next class how to balance using half reactions. And what you want to have balanced is how many electrons, right? Because iron had to lose 3 electrons to get this, right? So I can multiply everything by 3, right? And when I do it down here, it gives me my coefficients up here. But that's if we solve the whole reaction. Make sense? So where did chromium get the electrons from? The iron, right? Does that make sense?
Yeah.
Cool. Want to do another one? Yes, please. This was so much fun. Okay. I'll do it. You don't have to yell. I got it. ClO3 fluorate. And, this is not an ion, SO2. And it says here we get SO4 sulfate, -2, and the chloride ion. So if we assign oxidation states real quick, chloride ion being this would be -1, yeah. The sulfate, we know oxygen is -2, that's 8. The whole thing has to equal -2, so what's our sulfur? +6. Here, oxygen's -2, and there's 2 of them, so that's -4. What's our sulfur? +4, -9. So this whole thing equals -1. We know oxygen is -2, and it equals -1. So this is -6. So what's chlorine here? +5. So now, looking at the oxidation states between the reactants and the products, is there anything there that hasn't changed from one side to the other? Did the chlorine change? It went from +5 to -1. Yeah, that changed. Here, the oxygen is -2, and on this side, it's -2. Here, it's -2, and on this side, it's -2, right? So the oxygen hasn't changed, right? So the oxygen is not being oxidized or reduced. It's just there. So not every element has to be oxidized or reduced. But within the reaction, if one is oxidized or reduced, there has to be another one, and our other one is the sulfur, right? So you're going to be asked to write the half reactions. I'm just going to start at the beginning because that's what I do. So chlorine is going from +5 and it's going to go to Cl -1. How do I go from +5 to -1?
Gain 6.
Yeah, I'm going to gain 6 electrons. So this is, what's gain?
Reduction.
Reduction. So reduction is gain. So this is being reduced. Chlorine is being reduced. So this is the half reaction for chlorine. I don't do a half reaction for oxygen because it hasn't changed. But I am going to do a half reaction for sulfur. Sulfur is going from +4. Now, if this is reduced, we automatically know what sulfur is, right? It's going to be oxidized, right? Oxidation is lost. So if this one is reduced, this one, yeah, oxidation is lost. So when I lose electrons, that's going to be on the product side. So my electrons are going to be here. I know it becomes sulfur +6. How many electrons did my +4 lose? 2. 2. All right, so these are the half reactions. And later when we learn to balance, you would multiply this whole thing by 3, and that would give you the coefficients that go with them. But we'll learn that later. Make sense? So why don't you try the next 3 on your own? Why don't you try the next 3 on your own? And I will do them. Ooh, I'm going to freeze and I'm going to do them off screen and then we'll check your work. Or how about just the next 2? Don't want you to do too much if you're not doing it right. Why don't you check the first one, see how you did? Did you get +7 for manganese? And then the other side +2, so that's good. Oxygen didn't change, right? Hydrogen is +1 with nonmetals. So the one carbon had to be -2 to make that neutral. And the other carbon had to be 0 to make that neutral.
2 minus 2s and there's 2 plus 1s.
Oh, what? Did I do something wrong? 2 minus 2s and 2 plus 1s? So it's a +2.
So you just combine everything. It's just gonna be it's just gonna be
Shh.
-2.
It is -2 here.
But then the HCO.
Yeah, I made a mistake. What'd you guys put for here? This is -4 and plus this. This has to be what? +2. So I go from -2 to +2. +4? No, I go to +2, right?
Yeah, and then
Yeah.
the oxidation, it's
Plus
+4
4
electrons.
Oh, yeah, I got that. Yeah. Made a mistake. It's okay to make a mistake. Don't get mad at me. It's early. Did you guys get it right? It's way more important that you get it right than me. Okay, so now you're doing the next one? I'm just gonna email. What's going on here? Yeah.
It's decomposition.
So,
There's another reactant for transfer electrons.
yeah. Yep, cool. This is not giving you the information. So,
Question,
Yeah.
isn't it 4 for nitrogen on like the furthest one?
what?
Because it's -4 and it's a
Oh.
neutral atom.
What's a neutral atom?
Or,
Oh, yeah, yes, this is neutral. Yes. Okay, so this would be, yeah, because that's -4, so this would be +4. So we got we got this being +3 to plus 2. And we have this being plus 3 to plus 4. Do we have redox?
Yeah.
Which one's which?
What is oxidation? The first
Oxidation is lost. Reduction is gain. What? Crazy town. But it's decomposition. Crazy town. The same element being oxidized and reduced has a vocabulary word. What is that word? What is that word? What would you call the same element that's oxidized and reduced? What do you call it something like redox?
well, the fuse.
Yeah. So it's actually called. I'm not. Propanation. I can't be right. Hey Siri, what do you call an element that can be oxidized and reduced in the same reaction?
Here's what I found from infopiece.com. Common reductants, substances readily oxidized, the active metals, hydrogen sulfide, carbon monoxide,
Hey
and
Siri,
sulfurous acid.
when an element is oxidized and reduced.
Here's an answer from thefreedictionary.com. A substance is oxidized if it gains oxygen, loses hydrogen, or loses electrons.
Hey Siri, what is propanation?
Okay, I found this on the web for what is appropriate nutrition.
No. Oh. But I know this word. Protonate, not protonation. Is it pro? Ooh, is it diprotic? That's a 2. What is that called? Oh my God, what is that called?
Remember 5 minutes after you leave.
Right? I will remember 5 minutes after you leave. Yeah. No, it is not that word. It is a long word that doesn't seem to make any sense, but that's what nitrogen is doing right here. Do we want to do another one?
Sure.
So that is redox.
Yes, it is redox because of proper nutrition.
But if it doesn't do that, then it's not redox.
Right. So when you see the update, it's just one big word yelling at you. That's the word, guys. Okay, so what number are we on? Okay, let's go to something a little more interesting. Which one do you want to do, guys? Let's start at the bottom. Let's do copper and sulfate. Cu, it's all by itself, it's 0, and then SO4 minus 2. You would think it would just come together and make copper and sulfate, but we get Cu plus 2 and SO2, not a charge. And this is minus 2, so this must be plus 6. And this is minus 2, and this must be plus 4. Are you seeing a pattern in the column for oxidized and reduced? Did I screw this one up too? I did.
You just put copper on the outside.
What are you talking about? It looks totally fine. Okay. Sulfur is, so it goes from +6 to +4. So this is two electrons. How we doing, guys? Yeah? Okay. Now, you should have picked up another piece of paper. And it says Unit 6 practice problems. And it says, predict the products of the reaction and write the molecular equation. So this is just what does the equation normally look like. And then it says the full ionic equation. What? The full ionic equation? What the heck is that? For these double replacement reactions. And then it says assume one of the products is a solid. Which one? I'm going to show you. So, everyone on our first one. So this is kind of like what we were doing last time. Does anyone know the name of this first guy? Iron. No prefixes because this is not covalent. Iron 3, because it is a type 2 metal. Iron 3, and then what's this called? Iron 3 nitrate. And then it says AQ. What does that tell you? Yeah, it's dissolved in water, right? It's a salt that's dissolved in water, just like sodium chloride, but this is iron 3 nitrate, dissolved in water. So salt water plus NaOH. What's that called? Sodium hydroxide, right? Type 1 metal, so I don't need Roman numeral. We know that. And this is aqueous, just meaning that, it's in water. Now, outer, inner, what are we going to get? Well, iron is going to hook up with hydroxide. So what will be the formula? FeOH. What's going to be the formula when iron hooks up with hydroxide? So it's still iron 3 hydroxide. Boom. Right? Everyone get that? Yeah? Okay. And then sodium is going to hook up with what? The nitrate here. Sodium has a charge of +1 and nitrate is -1. So I'm just going to be able to write NaNO3. And then you have, so there we go. We've predicted the products. Those are our products. And it says here, assume one of the products is a solid. So you're actually going to do this reaction in class. And when one of them is a solid, it's called a precipitate. Meaning, here are two liquids. You're going to mix them together and you're going to make a solid. And one's still going to be a liquid, right? Still going to be aqueous. So the idea is, how on earth am I going to know what is what? How am I going to know what one's the solid and what one is what one stays in solution? There is something called a solubility table. And the solubility table, notice group 1, they all have +1 charges. Then we have group 2, they all have +2 charges. And here are some transition metals. And then here are your anions, both your group 17 anions and then polyatomic ions. So if we go back, what polyatomic ion is in the equation we're talking about? We got nitrate, right? So anything with nitrate, look at that, soluble. Ooh, if you see nitrate, it's soluble. That's kind of cool, right? Yeah. So that really helps. So where were we? Here. So this one, if it's soluble, that means it's going to stay aqueous. So if that one's aqueous, which one's going to be solid? The other one, right? The iron 3 hydroxide will be solid. So that's going to, when you mix these two together, that's going to come out of solution. It's going to be a color, or it's going to, have a texture to it. You're going to be able to filter it if you wanted to. You could stick it in the centrifuge and get it if you wanted to. But mixing stuff together. And if we want to see, well, what's making this insoluble? So it's iron hydroxide. We check out our hydroxide, and a lot of it's soluble. But look, here's the transition metal iron, makes it insoluble, right? So you'd be given this table to reference. So don't think you have to memorize it. You would be given this table to reference it. Do you understand how to read it?
Yeah.
Right? Your cations and anions. Makes it pretty easy. Again, don't think you have to memorize it. You can reference it. Knowing that nitrate is always soluble is kind of helpful because you don't have to look it up, kind of thing. Now, then it says the ionic equation. Well, when these guys dissolve in water, and it says they're dissolved in water, basically, they're not together. They're their ions, right? They're their ions. Oh, wait, do we have to balance this? Yes, let's balance. Let's balance. 1 iron, 1 iron. 3 nitrates. I got to put a 3 here, right? Okay. And then I have 1 sodium, 3 sodiums. So I got to put a 3 here. Now I have 3 hydroxide and 3 I'm balanced, right? 1, 3, 1, 3. We good?
Yeah.
Cool. So this is what you're going to put in for B, the molecular equation, balanced. And now we're going to do C. We're going to write it as C. I'm going to switch the color just because I can. What?
Isn't the instruction B is the full ionic equation, right?
Well,
Is that just
B, the full ionic equation. Oh, okay. Yep. B. Okay. So I'm doing B right now. Okay. We're going to imagine these split into its pieces. So Fe is Fe, and it's +3. Does that make sense to you guys? And then I have 3, see how there's 3 of them? NO3s. And that's -1. Because they're the ions, right? It's an ionic equation. And here I have 3 NAs, and what's its charge? +1. And I have how many OHs? 3 OHs, and what's that charge? -1. My arrow, I have iron over here. It's Fe +3. That makes sense, and there's just 1 of them. And then how many hydroxides? 3 OHs, right? So I have 3 OH minus. And then here I have what? 3 sodiums at +1. And then what else do I have? 3. Remember, this 3 distributes over. Yep. 3 NO3, and they're minus. Oh, wait. This one's solid. My bad. You don't, when it's solid, it doesn't separate, right? It's not in ions, it's solid. That's the whole point. We got FeOH3 solid. What do you think, guys?
Do you have to write the states for the other one?
Yeah, you're supposed to. Aqueous. Doesn't this kind of look like that dissociation stuff? So these are all aqueous, meaning they're in water, and this one is solid. So if it was on a beaker, it's going to be on the bottom. You're going to use well plates, so it's going to be on the bottom of the well. So here is your solid. So then, yeah, it says include the states of matter. Identify the spectator ions in each reaction. A spectator ion is one that is on both sides of the reaction. And basically, just like algebra, if they're on both sides of the yield sign, I can cancel them out. So 3 nitrates. Are there 3 nitrates over here?
Yeah.
Yep. So nitrate is a spectator ion. NO3 minus is a spectator ion. Basically just watching. Just watching what's going on. What else is a spectator ion? 3Na plus. 3Na plus is a spectator ion. So it's just Na. The amount doesn't matter. That is the ion. In solution, that is just hanging out. It's on both sides. So those are the spectator ions. D, so identify the spectator ions in each reaction. So this is the full ionic equation. Let's do the net ionic equation. The net ionic equation is this equation without the spectator ions. So we're literally just going to rewrite it without the spectator ions. So what do we have? We have Fe, right? Here. And then it's plus 3. And we have 3 OHs minus. And yes, AQ. Yes, AQ. And we get FeOH3 solid. That is our net ionic equation. Okay. So all this is going on, right? You got to put all these together. But this is what really is happening, right? You're really making iron 3 hydroxide, right? Because these are in solution, and this is really what's going on in the equation. Does this look like fun? Do you have an earbud in? Take it out. You could be jamming this. Oh my God, you both are listening to music back there. Having a good time, are you? You want to do another one? Okay. Insert new slide. Blank. Okay. We have HI. Hi. And no. Okay. So hydrogen mono iodide, because no metal here, right? And zinc. You don't have to say 2 because the whole world knows that's an exception. So this is just zinc nitrate. What are we going to get? Outer, inner. HNO3, right? This is -1, this is +1. HNO3. And what else? Zinc and iodine. Zinc is what charge? And iodine is what? Because it's in 17, so this should look like that, right? Now, one of these is solid. When did we learn about nitrate?
Nitrate is always aqueous.
Yeah, so this one has to be the solid one, right? So the rest of these are AQ, dissolved in water, right? And then let's balance. We got 1 hydrogen and 1 hydrogen, 1 iodine and 2 iodines. So let me put a 2 here, right? Well, now I have 2 hydrogens. so I have to put a 2 here. Well, 2 nitrates and 2 nitrates, 1 zinc and 1 zinc. So 2, 1, 2, 1. Look good? Okay, so there's my equation. Now, I'm going to, if it's aqueous, it's going to be split into its ions. Remember how water kind of pulls the salt apart? That's what we're doing. We're just showing it with the salt apart. So we'll have 2 H pluses and 2 I minus and Zn plus 2 and 2 NO3 minus yields 2 H plus and 2 NO3 minus and ZnI2 solid. If it's solid, it's not in ions, it comes out of solution. Now we want to drop our spectator ions. 2H and 2H is a spectator ion. 2 nitrate and 2 nitrate are my spectator ions. So if I rewrite it, if I write my net ionic equation, 2 iodides aqueous and Zn plus 2 aqueous yields ZnI2 solid. What do we think? Yeah? Oh, I wonder if I can do this. Oh, no. Okay. Well, I kind of like that writing. We're going to get a little smaller. Let's put it up here. So we all get that. Here's a beaker.
Can I use the background?
Yes, you may. Here is a beaker. And I'm going to make a little legend. I'm going to say my H pluses are open circles. My I minus is a little closed circle. My zinc plus 2 is an open triangle. And my NO3 minus is a closed-in square. Does that make sense to everyone? So I'm going to mix these two solutions together, and I'm just going to, each one's going to be a mole. So I need 2 H pluses. So there's 1, 2. They're in liquid, just random, floating around. And 2 of the I's. So I got 1 here and 1 here, completely random, just floating around. And I only have 1 zinc, so I've got a triangle here. Boom, boom, boom. And then I have 2 NO3s. This is before. Does that make sense to everyone? That's what it looks like before. It's a particle diagram. This is what it looks like before. We'll be starting to do a lot of particle diagrams, especially in your lab book. So then, what does it look like after? Well, first, our zinc iodide is a solid. Well, where does a solid end up? On the bottom. And zinc is a triangle, and then it's attached to 2 iodines. There's 1 and there's 1. So they are touching, and they are sitting on the bottom of the container. That tells you it's a precipitate. Right, this is a precipitate. It's going to be on the bottom, and they are touching. Now, what else is in solution? I still have 2 hydrogens. And what else? 2 NO3s. So I have 2 NO3s. This is after. And then, I don't know, let's say it's a certain amount, right? It's in water. Right. Make sense to you guys? Particle diagrams? Would you be able to draw a particle diagram before and after mixing 2 salt solutions as part of your FRQ, as part of your labs? See how I did that? Right. That's why we're even splitting these up into the ions. Remember when they're aqueous? Oh, shoot. Yeah, you got to put AQ for all these. Oh my God. You know what this means, don't you? Because I grouped it. My aqueous. Okay, let me try that again. I want my aqueous. Boom. Okay. What do you think? Pretty cool? Okay, so for the rest of class, you don't have to do these diagrams, but you have 1, 2, 3, 4, 5 on this page to do. And on the back of your redox, do at least 5 more and only finish it if you need to. But do at least 5 more on the back of the redox page, right? Because we did 5, 1, 2, 3, 4, 5. We did 5, so you do at least 5. And so you got 10 problems to be done. Yeah? Okay, cool. And I am going to come around with, I owe you 2 stamps. I love my stamps. I did not stamp last class at all. That's why I know I owe you 2. And remember, you only had to finish the 1 worksheet for today. And And then the one for today, you were only supposed to have the front of. Yeah, no, this one, the front of this, because we just worked on the back of this, right? So just the. You can read the top of the page, Baby Junior, right? Yeah, Baby. Oh, that's his?
I'm just finding the, just know which ones you're checking, so I don't know. This is the.
Any questions on identifying types?
I remember checking against these, I think you did it.
And predicting products?
Those are predicting things. Yeah.
Outer dinner, right? Identifying types, predicting products, and then the first page of the oxidation. Types of reactions. No. Me.
Yeah. You can see like drive. And they're like still stuck. Yeah. Oh, I don't. Oh, yeah. Why are you so shocked? I don't know. I don't know when it's. Wait, it's just negative, but it's really like adding. Like it's like more numbers, but it's like off. Like so it's like. Yeah, it's like it's going up, but then yeah. It's like all the
Yeah. That's the first one. Unit 6.
What was
He's
it?
gonna check for this, and then you have the other one.
I worked on the designing occupational performance system.
That and this.
I finished this. What day are we assigned? I think it was actually.
Fourth one.
Why didn't you come see me during rehearsal? Did everyone get a stamp?
I did not. I was in the
Right, then that's good.
Predicting
-2, and then
which sheets do you stamping for?
-2, and then
Types of reactions.
I don't think because that's still just like yeah. So I it's just still more. Yeah.
you're
Types
right.
of reactions, plastic.
Wait, so it can't be.
Are we stamping for this or no?
This was part of. Where's your types of reactions?
I worked on it.
I'm gonna do this. So what I'm gonna do here, this can't work because it's
So,
not.
next stamp, we're looking for 5 more of these, right?
Doesn't matter which one.
And only 2 more if you're not getting it. You're not understanding.
Wait, you could have 30. Okay, you can explain it.
Remember, this is just parts of the equation. I just pulled out some of the equation, like there's more going on than just that.
Yeah. February.
Yeah, today's the first.
So you're getting
And the third stamp should be, which one was it? The 8th.
and then stuff. So you look it up. You should have flashcards, maybe in your table. Because we're not your cards. You can go somewhere with pull out your cards for the polynomial guide. So,
I don't know.
yeah, so
Oh, I don't know.
No, but have you guys been to the third one
Wanna
yet?
have those kind of references close.
Which one?
Oh, I was starting. I did, Alex did. I didn't think I was, that's what
Never
I'm
do.
Maybe
Isn't
I'm
the homework this
just
week?
more.
It's 5 of
It's 5 of those and the rest of the other.
And they're.
I don't know what it is.
Probably
Is it just
just.
NaCl?
So the ratio of NaCl there's 2 CLs.
Because NaCl and
I it doesn't mean you amount it.
But then.
And you there have to be 2
But then if it's like that, I don't think it's like
So, the subscripts don't go with it, and it's polyatomic ion. The polyatomic ions, they stay together as a group. But other than that, that's what the oxidation table is for, so you get the formulas, right? Then you come up with one that you just can't balance or if you don't check your formulas.
Place that.
Let's see, like you say, that by itself should be 0, right?
Well, let's test your formulas first, your calcium phosphate from. Phosphate is -3. So when you first drop, you have to know your polyatomics, guys.
Any element by itself is 0, even if it doesn't matter how many there are.
Well, there can only be like 1, 2, or 8.
That works.
Yeah. So I got S.
Okay, so right, NaCl plus 1 minus 1. So the ratio is.
I didn't get that one.
There's 1 N for every CL. The thing is drawn solid.
Oh, you want?
There's 3
You need the yeah, the graph to pull out. Okay, but what about this? Yeah, how's that? Yeah. I just looked at like, I got, yeah, more. No, I had it.
If nothing else, at least figure out what's soluble and insoluble before you leave today. That will really help. Absolutely, you can take a picture of that.
Well, that can be real.
Oh.
Miss Johnson?
Hmm.
Well, that can be.
I can.
They're like cropped over. That was stupid.
I don't like the type word. I don't like
Like, I think I forgot to take my notes. What do you think it is? Everything. Everything. Like 5 different options.
Oh Lord, I had
It's fine. I did the entire one because I lost it. So.
I did draw it.
Okay. Every number I had is important and I could double it.
Pretty much.
Oh,
double side.
wait, no, I know. Yes, I do. Yeah.
So let me just save this. And which one are we doing here?
The third one here.
I've got it right down. Third one is calcium chloride. CaCO2. We know that this is +2 and this is -1. And we got Na3PO4. Why? Because PO4 is -3 and sodium is +1. So we will get Ca3PO42 calcium phosphate. And
Wait, I got PA3 and
PO4 what? The 3 phosphate is -3. That's where this 3 is from. Calcium is +2.
Oh, yeah.
Okay, and NaCl. Yeah, if you can't balance, your formula's wrong.
Yeah. Okay, thank you.
Do we want to write it as 3Cl2 or just 6?
6 Cl2 minus. So like if you were drawing the beaker full,
Oh,
it'd be
because they're
6
diatomic,
Cl.
they'd stick together.
Well, no, because it's in one. They're ions. 6 Cl minus.
Okay.
Right? That is not Cl2 because it's diatomic.
Oh, it's just that because it's cold.
Okay. It needs 2 negative charges to go with the calcium. Right? So when this splits up into 1 calcium and 2 different chloride ions. Right? They don't form a covalent bond from an ionic bond. Right? This is a metal anomaly. Thank you. Yes. You're not balancing. These are just pieces of reactants. You're not trying to balance. You're putting the charges and finding out which one's oxidized and which one's reduced.
Yeah.
Right? There's no balancing to be had. So oxygen -2. The whole, so that's 3 of them. So it's -6. So this must be +5. The whole thing has to equal +5. And then anything by itself is 0. And diatomics are 0. This whole thing is -1, that must be +5. Iodide has to be +5 here, so oxygen -2. Here 4, one of those. So this is -2, this has to be +3. Right? Because they come together to then you see which ones are different, and then you which ones be an oxidized. So this is not Na3, it is 6 Na. Right? So these subscripts only go when they're balanced.
Every single day.
Down here, this is the ratio. Okay, this is the ratio. I need 3 sodiums for every 1 phosphate. Because phosphate is -3 and sodium is +1. The fact that you then balanced it, that you need 2 of these total, that means you have 6 sodiums. This Cl2, that doesn't stay there. Again, this 2 is for here. This just means for every 2 plus, I need 2 chlorines. Right? For the spectator ions?
Yeah, like,
just the ions.
oh, okay.
Yeah, because they're in the beaks. So which one are the spectators? They're all individual when they're in the beaks.
What's our homework for today? Back of the
You're finishing this. You finished it?
I'm finishing it.
Okay, you're finishing that. And then the back of the oxidation sheet, at least 5 or more if you're not understanding it.
At least 5 of them.
At least 5 additional ones. We did 5 together in class. I want to see 5 additional ones completed correctly. So when I go to give you a stamp, if I see that they're wrong, I'm going to ask you to do more to get the stamp. So you want to do them so you feel comfortable doing them.
Mr. Martin, call me Rachel. Okay. Hi, Rachel. Rachel's here right there. Wait, we're gonna do.
Solubility tables on school at G.
Yeah, just this is gonna be my elective. Let me do mine. This is gonna be my elective. Let me do mine first. This is why I sit over there.
It's not a bother. Yes.
So I know you don't have like quantities, but would you still say CL2?
No, because it's not CO2. And it's not CO2 here. So this is Ca, calcium. It's right, and this is +2, -1, -1. Together, it's CaCl2, right? In water, it splits up, right? Now, if it were to then be with a +1, I only need 1 Cl. So even though this formula is CaCl2, if this was sodium, when chlorine is with sodium, it's just NaCl, right? And then in water, it looks like that because it's surrounded by water molecules, right? So when let's do 2 of these. Let's say you balance it. Right? Let's say you balanced it and you have 2 CaCl2s. And I'm asking for the net ionic reaction. So aqueous is in solution. I'm going to say 2 Ca + 2 and 4 Cl-.
Yes, that makes sense.
Make sense?
Yeah, thank you.
Sure.
Oh, okay. Okay.
If you buy it twice. How do you buy it? I'm not supposed to be. Yeah. I don't know how to do like this. So I'm just curious, how do you know like if it's two that goes
You don't. You never do. There's nothing to know. The answer is no. Okay, so this down here, these guys, unless it's a polyatomic ion, it doesn't carry over. Okay? It might, by coincidence, end up being the same. but it never carries over. So you know you're putting your calcium and your phosphate together, and you know you're gonna have your sodium element and you're gonna have your fluoride element. Okay? Then, forget that. Forget that. Oxidation states. This is +1 because it's in group 1. Chlorine is -1 because it's in group 17. So when they come together, that is the formula for sodium chloride. Okay? Calcium +2. Right? Phosphate -3. I memorized it. Let's say I forgot. 3 came from there. Right? So that'll tell me. So this is -3. So when I crisscross applesauce, I need 3 calcium for every 2 phosphates. So this is +2, +2, +2, -3, -3. Right? There's 2 -3 for every 3. So you never carry over the D position. The D position is unique. Kind of like you act different in front of your parents than you do in front of your friends. Right? Totally normal than you do in front of a doctor. Right? So elements do the same. They're going to be different depending on who they're with. So the numbers and the ratios that they combine in are different. Right? Charges, not so much. Right? That's why the oxidation states are for the periodic table. Well, sometimes the charges change, but only in redox. If you have the same thing on both sides, it's not a redox. Right? Because we're not talking combustion, we're not talking a single replacement of redox. Right?
What's the trouble? Oh wait, yeah, that's on the board. I was thinking of
That's not good. Just throw it out.
And then can I pick?
No, that's not yours. No, that's not yours. I put yours away already. You're coming so late. I'm probably for AP. That's what happens when you come 3 minutes before the end of class. Oh, that's fine. No, that's fine. I'm just don't pick up the AP.